Hi friends, welcome to all. In this video we are going to see the lab activity configuring dynamic and static NAT. Before coming to this lab activity, friends, if you are watching my channel first time or if you are not yet subscribed this channel, consider subscribing. Also enable the bell icon near to the subscribe button so that you will get the notification message whenever I upload the new videos. Here we can see our topology diagram. Also a tracing table. We will go through the objectives of this lab activity. In part 1, build the network and verify connectivity. In part 2, configure and verify static NAT. In part 3, configure and verify dynamic NAT. Also we will go through the background. Network address translation (NAT) is the process where a network device such as a Cisco router assigns a public address to host devices inside a private network. The main reason to use NAT is to reduce the number of public IP addresses that an organization uses because the number of available IPv4 public addresses is limited. In this lab, an ISP has allocated the public IP address space of 209.165.200.224/27 to a company. This provides the company with 30 public IP addresses. The address 200.2252, 200.241 are for static allocation, and from 242 to 254 are for dynamic allocation. A static route is used from the ISP to the gateway router, and a default route is used from the gateway to the ISP router. The ISP connection to the internet is simulated by a loopback address on the ISP router. Here we can see the required resources: 2 routers, Cisco 1941, 1 switch, Cisco 2960, 2 PCs, console cables, and Ethernet and serial cables as shown in the topology. Coming to part 1, build the network and verify connectivity. In part 1, we will set up the network topology and configure basic settings such as the interface IP addresses, static routing, device access, and passwords. Now we will come to step 1, cable the network as shown in the topology. Attach the devices as shown in the topology diagram and cable as necessary. We are going to build and connect this topology on our Cisco packet tracer. 2 routers, 1941, 2960 switch, 2 PCs. We will rename these devices. This is PC-A, PC-B, this is S1. Here we have gateway. This is ISP. Now we will connect these devices. Coming to connections, copper straight through, S1 F0/6 from this PC-B to F0/18, F0/5 to G0/1 on this gateway. And here we have to add the serial interface. Coming to the router gateway, and we are going to put it off. Here we are going to add 2-port serial high-speed WAN interface card. Coming to ISP, now we are going to select serial DCE. So here we can see a DCE side is on ISP. So we will start from ISP serial 0/0/0 to serial 0/0/1 on gateway. Now we will label all the information. This is a simulated server. Here we connected to F0/6. Here we connected to F0/18. This is F0/5. Here is a G0/1. Here we have serial 0/0/1. This side is a serial 0/0/0. This side is a DCE. So here we have a simulated internet services. Now we will come to step 2, configure PC host. Coming to our addressing table, here we can see the IP address, subnet mask and default gateway of the devices PC-A and PC-B. First of all, we will get the IP address of PC-A simulated server. Here we can see the subnet mask and the default gateway. Desktop IP configuration. Here is the IP address, subnet mask, default gateway is 1.1. Here we can see the IP address of a PC-B. Subnet mask default gateway is 1.1. Coming to step 3, initialize and reload the routers and switches as necessary. Okay, we will come to step 4, configure basic settings for each router. Console into the router and enter global configuration mode. Copy the following basic configuration and paste it to the running configuration on the router. So here we can see the commands. Coming to the router, gateway CLI. Now enable configure terminal. Here we are going to paste those commands. Also we will paste it on the router ISP. Now enable configure terminal, and here we are going to paste those commands. Coming to C, configure the host name as shown in the topology. Also we have to configure the interface IP address as per our addressing table. Here we can see the details. First of all, we will do it on the router gateway. We will set the host name as a gateway. Now we will set the IP address for the interface. First we will set the IP address for the interface G0/1. Interface G0/1. IP address, so here is the IP address. Also the subnet mask 255.255.255.0. No shut. Now we will go to the interface serial 0/0/1. Here we can see the IP address in the subnet mask. Interface serial 0/0/1. IP address in the subnet mask 255.255.255.252. No shutdown. Copy running config, startup config. Now we will do it on the router ISP. Host name as ISP. Here we can see the IP address of the interface serial 0/0/0 on this device ISP. Also we can see the subnet mask. So we will go to that interface serial 0/0/0, IP address, the subnet mask 255.255.255.252. Now shut down. Now we'll go to the loopback interface. Here we can see the IP address. Also we can see the subnet mask. Interface loopback 0, IP address, the subnet mask 255.255.255.255. Copy running config, startup config. D. Copy the running configuration to the startup configuration. Have we done that on both routers? Now we will come to step 5. Create a simulated web server on ISP. Yeah, create a local user named web user with an encrypted password of web pass. Here we can see the commands. Then enable the HTTP server service on ISP. Then configure the HTTP service to use the local user database by giving this command. We will do that on the router ISP. Coming to the router ISP, configure terminal, username as web user, privilege 15, secret as a web pass, IP HTTP server, here we can see this command is not supported with our Cisco packet tracer. Even this command also not supporting. Anyway, in the real router we can give these commands. Now we will come to step 6, configure static routing. Create a static route from the ISP router to the gateway router using the assigned public network address range 209.165.200.224/27. Here we can see the command. Also we have to create a default route from the gateway router to the ISP router. We will do this now on these routers. First of all, we will do it on ISP, IP route. Here is the address. Then we have to specify the destination prefix mask 255.255.255.224. Now we are going to give the forwarding router's address. It's 201.18. Now we'll do it on the router gateway. Cisco enable password is class. Configure terminal IP route 0.0.0.0 space 0.0.0.0 space. Here we have to specify the forwarding router's address. Here is that. Copy running config, startup config. Coming to step 7, save the running configuration to the startup configuration. Here already we have done that. Coming to ISP, copy running config, startup config. Now we will come to step 8, verify network connectivity. From the PC host, ping the G0/1 interface on the gateway router. Troubleshoot if the pings are unsuccessful. So we will get the IP address of G0/1 of the device gateway. Here is that. First of all, we will do it from PC-A, command prompt, ping to the interface G0/1. Here we can see we are getting the replay. Coming to PC-B command prompt, ping to the router gateway interface G0/1. Here we can see we are getting the reply. So the pings were successful. Now we will go to B, display the routing tables on both routers to verify that the static routes are in the routing table and configured correctly on both routers. Coming to gateway, show IP route, and here we can see the default route. Coming to the ISP, show IP route, and here we can see the static route we created on this router. Now we will go to part 2, configure and verify static NAT. Static NAT uses a one-to-one mapping of local and global addresses, and these mappings remain constant. Static NAT is particularly useful for web servers or devices that must have static addresses that are accessible from the internet. Coming to step 1, configure a static mapping. A static map is configured to tell the router to translate between the private inside server address 192.168.1.20 and the public address 200.225. This allows a user from the internet to access PC-A. PC-A is simulating a server or device with a constant address that can be accessed from the internet. Coming to the configuration on the router gateway, configure terminal. Here we are going to give IP NAT inside source static. Here we are going to give inside local IP address. It's 192.168.1.20. Now we are going to give inside global IP address. It's 209.165.200.225. Coming to step 2, specify the interfaces. Issue the IP NAT inside and IP NAT outside commands to the interfaces. So here we can see those commands. For the interface G0/1, it's IP NAT inside, and for the interface serial 0/0/1, IP NAT outside. So coming to gateway, first we will go to the interface G0/1. Here IP NAT inside. We'll go to interface serial 0/0/1, IP NAT outside. Now we will come to step 3, test the configuration. A, display the static NAT table by issuing the show IP NAT translations command. Here itself they given the show command, show IP NAT translations, and its output. Here we can see that inside global, inside local. Coming to gateway, here we are going to give show IP NAT translations, and here we can see the output. What is the translation of the inside local host address? 192.168.1.20 is equal to, here we can see in our show IP NAT translations output, it will be the inside global address 209.165.200.225. Next is the inside global address is assigned to by, obviously by the ISP and NAT pool. Next is the inside local address is assigned to by, it's by the administrator. Now we will come to B. From PC-A, ping the loopback 0 interface, that is the address, here we can see that, on ISP. If the ping was unsuccessful, troubleshoot and correct the issues. On the gateway router, display the NAT table. So first we have to ping from PC-A to this loopback 0 interface with this IP address. We will do that. Coming to PC-A, command prompt, ping to loopback 0. Here is the address, and here we can see we are getting the replay. Now we are going to give this a show command, show IP NAT translations on the router gateway. Coming to the router gateway, enable class show IP NAT translations, and here we can see that, but it's not showing here. So what we will do, we will ping once more. Now we will come back to gateway router and we will give the show command again, and here we can see the result. A NAT entry was added to the table with the ICMP listed as the protocol when PC-A sent an ICMP request to 192.31.7.1 on ISP. What port number was used in this ICMP exchange? So here we can see 4 ICMPs with different port numbers. This first line used 13, then here we can see 14, then on third line we can see 15, and fourth line we can see 16. So here maybe your answer also may vary. So it may be necessary to disable the PC-A firewall for the ping to be successful, right? So coming to C, from PC-A, telnet to the ISP loopback 0 interface and display the NAT table. Now we will come to PC-A, command prompt, and we will telnet to loopback 0. Here is the address. Password is Cisco. Enable password is class. Here we can be able to get the router ISP. Now we will come back to gateway. Show IP NAT translations, and here we can see the details. They given a note here. The NAT for the ICMP request may have timed out and been removed from the NAT table. Yes, here we can see that it's removed. What was the protocol used in this translation? Here we can see the protocol. Here is a TCP. Next is, what are the port numbers used? Here we can see the port numbers used, 1025, 23, and 23. Here we can see 1025. Inside global bar local, here we can see the port number, it's 1025. Outside global or local, here we can see it's 23. This is the port number for the telnet. Here this inside global bar local port number may vary. Coming to D, because static NAT was configured for PC-A, verify that pinging from ISP to PC-A at the static NAT public address, that is to this address, is successful. Coming to the router ISP, enable password is class. Here we are going to ping to this address, and here we can see success rate is 100%. E, on the gateway router, display the NAT table to verify the translation. Coming to gateway, here we are going to give IP NAT translations, and here we can see the output. Notice that the outside local and outside global addresses are the same. This address is the ISP remote network source address. For the ping from the ISP to succeed, the inside global static NAT address, that is a 209.165.200.225, was translated to the inside local address of PC-A. Here we can see that 192.168.1.20. Coming to F, verify NAT statistics by using the show IP NAT statistics command on the gateway router. Here also they given the output for that show command. We will give on this router gateway show IP NAT statistics. Here we can see the output, total translations, one static, one dynamic, and one extended. Outside interfaces, inside interfaces, expired translations. Right. Note this is only a sample output. Your output may not match exactly. Right. Coming to part 3, configure and verify dynamic NAT. Dynamic NAT uses a pool of public addresses and assigns them on a first come first served basis. When an inside device requests access to an outside network, dynamic NAT assigns an available public IPv4 address from the pool. Dynamic NAT results in a many-to-many address mapping between local and global addresses. Coming to step 1, clear NATs. Before proceeding to add dynamic NATs, clear the NATs and statistics from part 2 by giving this command, clear IP NAT translations star, clear IP NAT statistics. Coming to the router gateway, here we are going to give a clear IP NAT translations, then star, deletes all dynamic translations. Also we are going to give a clear IP NAT. We'll check that here. Here we are not getting the statistics. Right. Now we will come to step 2, define an access control list that matches the LAN private IP address range. ACL1 is used to allow 192.168.1.0/24 network to be translated. So we are going to create this access list 1 on this router gateway. Coming to the router gateway, configure terminal. Here we are going to create the access list 1. Here we are going to permit 192.168.1.0 network. Also we are going to specify the wildcard bits 0.0.0.255. Coming to step 3, verify that NAT interface configurations are still valid. Issue the show IP NAT statistics command on the gateway router to verify the NAT configurations. So coming to our router gateway, show IP NAT statistics, and here we can see the details. Now we will come to step 4, define the pool of usable public IP address. Here we can see the command what we have to give on the router gateway. Coming to the router gateway, configure terminal IP NAT pool. Then we are going to specify a pool name, public_access. Then we are going to give a stat IP address 299.165.200.242. Then we have to specify an end IP address 209.165.200.254. Then we have to give a net mask, and we have to specify the network mask. It's a 255.255.255.224. Coming to step 5, define the NAT from the inside source list to the outside pool. Remember that NAT pool names are case sensitive and the pool name entered here must match that used in the previous step. Right, so this is the command that we have to give. Coming to the router gateway, here we are going to give IP NAT inside source list is 1 pool. We have to specify the pool name, public underscore access. Coming to step 6, test the configuration. From PC-B, ping the loopback 0 interface using this IP address on ISP. If the ping was unsuccessful, troubleshoot and correct the issues on the gateway router. Display the NAT table. So here itself they given the command and the output. Show IP NAT translations, and here we can see the output. Inside the global, inside local, also we can see outside local and outside global. Coming to PC-B command prompt, here we are going to give the command ping to this loopback 0, and here we can see we are getting the replay. Now we will come to gateway, and here we are going to give show IP NAT translations, and here we can see the output. What is the translation of the inside localhost address for PC-B? Coming to our output, here we can see that inside global, here is the address. A dynamic NAT entry was added to the table with ICMP as the protocol when PC-B sent an ICMP message to 192.31.7.1 on ISP. What port number was used in this ICMP exchange? So coming to our output, here we can see, here we have 4 ICMP protocols. So here we used 7, 8, 9 and 10. Now we will come to B. From PC-B, open a browser and enter the IP address of the ISP simulated web server loopback 0 interface. When prompted, log in as a web user with a password of webpass. Anyway, this is not going to work in our Cisco packet tracer. In the beginning we have seen IP HTTP server command not accepted in this Cisco packet tracer. So in the real time you can do this. Anyways, we will come to see display the NAT table. Here we can see, here they given the output for that. What protocol was used in this translation? Here we can see it's a TCP. And what port numbers were used inside? Here used, we can see 1038, 1039, 1040, etc. And outside we can see it's 80. What well-known port number and service was used? So it's 80. This is for HTTP. Coming to D, verify NAT statistics by using the show IP NAT statistics command on the gateway router. Here we can see that show IP NAT statistics. Total active translations 3, 1 static, 2 dynamic and 1 extended. Also we can see access list 1 pool, right? Also we can see these details here, start address and the end address, right? This is only a sample output. Your output may not match exactly. Now we will go to step 7, remove the static NAT entry. In step 7, the static NAT entry is removed and you can observe the NAT entry. Remove the static NAT from part 2. Enter yes when prompted to delete child entries. Here we can see that command. Yes, we will do that. Coming to the router gateway, Cisco enable class show running config, and we will copy this line. Configure terminal, and here we are going to give no, then we are going to paste that line we copied. Here is that. Right. Next is clear the NATs and statistics. Coming to the router, clear IP NAT translations. Coming to C, ping the ISP 192.31.7.1 from both hosts. Coming to PC-A, command prompt, ping 2. We are getting the replay. Now we will come to PC-B, command prompt, here we can see we are getting the replay. Now we are going to give display the NAT table and the statistics, show IP NAT statistics, also show IP NAT translations. Here we can see the details. Total translations 8, 0 static, 8 dynamic, 8 extended. Here we can see the details. Also we will give show IP NAT translations. Here we can see the output. Here we can see this all these 4 from one PC and these 4 from the other PC. Also we can see the inside global address here, 242.243. Right. This is only a sample output. Okay, we have seen that. Coming to reflection. First one, why would NAT be used in a network? Obviously, first of all, whenever there won't be enough public IP addresses, then we will use a NAT. Also, NAT can provide a measure of security by hiding internal address from outside networks. Coming to the second question, what are the limitations of NAT? Yes, NAT needs IP information or port number information in the IP header and TCP header of the packets for translation. So here is a partial list of protocols that cannot be used with NAT, such as SNMP, LDAP, etc. Well, that's all in this lab activity, configuring dynamic and static NAT. Friends, if you have any doubt in this lab activity, please comment below. Also, if you like my video, give a thumb and share with your friends. And finally, don't forget to subscribe this channel so that you will get latest uploading video info directly into your Gmail. Thank you.